just tell me so don't be worried Saya tak ada makan orang, saya tak ada ingat nama awak lepas tu turunkan markah, tak ada any feedbacks from you is good enough, okay? You can just chat with me or you can just show your feedbacks through wordings ke, nak cakap apa-apa, cakap dengan saya. Or if you have any problem, just personal message me, okay? Saya tak ada masalah. Nur Adlin, okay?
Okay, sir.
Okay, alright. So we are going to continue with this. Okay, so now saya continue dengan chapter 4. Kejap ya. Window, chapter 4. Alright, so this is chapter 4.
Sir,
Yes.
video-video sebelum ni dekat YouTube, sir?
Ada. Saya sebenarnya ada limitation kat laptop saya. Hari tu saya punya PC pun dia macam terburn out sikit, so saya tak boleh nak compile semua video. Tapi this week saya dah settlekan dah. And ada rezeki saya beli laptop baru, so should be okay lah kot. Nanti saya upload semua benda Apa-apa saya update semua dalam Google Classroom. Alright?
Okay, thank you, sir.
Okay, sure. Slides pun saya akan bagi dalam Google Classroom juga, so don't worry. Semua akan saya upload lah slowly Untuk memudahkan kerja saya beli gaming laptop lagi, tapi yang paling cheap yang ada lah Hopefully everything will work fine. Okay. Alright, so this is MEM 341, Chapter 4, Actuators. Okay, I am fortunate to do a slideshow on this, so we can go through the slideshow together. Okay, I will give this slideshow in terms of PDF later on. Okay, so in Chapter 4, what we are trying to complete is to understand or identify the various types of mountings and mechanical linkages for transmitting power. Number 2, to describe the functions of hydraulic cylinders and motors. And number 3 is to calculate the load carrying capacity, speed and power. Okay, so what we are trying to learn for this week is, last week we learned about pump. Okay, so pump is the heart of your system. It means from there you increase the pressure will be used in order to flow the liquid from one point to another. So what we are dealing right now is we are flowing the liquid from one point to another point, and at the end of that, the applications that we are going for is actually called as actuators. So all the pumps are used in order to increase pressure so that liquid will go to your actuators and it will move the actuators. So that is the reason why we are learning pump first, then we learn about actuators. Okay. So actuators extract energy from fluid and convert it into mechanical energy to perform useful work. Okay. This one is different than pump. Pump, what happened is electrical energy is used to spin the pump, and now pump has a mechanical energy. When fluid flows into it, the pressure of the fluid increases. So from there, what happened is you transfer from mechanical into fluid energy. So that is what happening when you are dealing with pump. However, when you are dealing with actuators, it is the other way around. Okay. So let me put it here. Okay, so if you are talking about pump, so what happened is you are converting from mechanical energy into fluid energy or fluid flow energy. Okay, and what happened when you have actuators? Okay, you are transforming from fluid energy into mechanical energy. Okay, so what happened in between? In between here, from pump to actuators, you will have your conductors. Okay, what is the conductors? Conductors are pipings, tubings, a way for you to move from the fluid from the pump to the actuators. Okay, so actuators can be classified into two different motion. Number one is linear motion. Linear means it's moving in a linear condition like this or like this. A good example of a linear motion is when you have this picture over here. Okay, the movement is from here going out, all right, and then coming in. Okay, usually you use piston, okay, and cylinder. Okay, piston, rods and cylinder. Okay, the second one is rotational motion. Rotational motion means we are dealing with rotations. It's either this way or this way. Okay, and in rotational condition, it is the same as pump. We have vane, piston, and gear. Sorry, gear, vane, piston. We still have rotational in terms of different rotation for piston, but usually, if you are talking about rotational motion, we have these three. Okay, so the same as pump, we have vane, piston, and gear. This one we have a linear motion or hydraulic cylinder. So this one is what we call as hydraulic cylinder. Okay, so to differentiate between these two, okay, so we have these two different type of motion. Number one is linear motion. It is expressed as linear actuator. Oh, sorry, it's a typo here. So actuator, okay, right, cylinders, has a push or pull force to move load strong along a straight line. So the meaning here is it is moving in a straight line. It doesn't matter vertical or horizontally, as long as it's in a straight line, it is linear motion. Number two, it is called as rotational motion, known as rotary actuator. Rotate a shaft to provide torque to drive a load along a rotary path. So this one in terms of straight line, this one in terms of rotary. So straight line or rotary. Okay, this one we use a force F, okay, and here we are using torque T. Okay, so torque and force, they are different things. Okay, so if we differentiate between hydraulic actuators in terms of linear actuators, we have single acting cylinder or double acting cylinder. We will introduce to you these two particular cylinder later. And rotary actuator, we have rotational, limited rotational motor or continuous rotational motor. Limited means it can spin up until a certain degree. For example, this is your shaft. It might spin up until 180 degree to the right or to the left like this. Okay. Or if you have a continuous rotational motor, it means your motor can spin in a loop. Okay. So 360 degree. All right. So it doesn't mean that it's 180. It can be much more. It means it has limitation. All right. But for continuous rotational motor, it spins in a loop or it can spin all the way around. Okay. So your motorcycle, is it limited rotational motor or continuous rotational motor? Ahmad Amirul.
Continuous.
Ahmad Amirul, are you there?
Yes, sir.
For a blender, for example, is it continuous rotational motor or limited rotational motor?
Itu continuous.
Continuous, eh? Okay, why? Because it can spin continuously, correct? So that's a continuous rotational motor. Luqman Hakim, are you there? Luqman
Yes, sir.
Hakim? Yes. So can you think of an idea of a limited rotational motor?
Ush.
Can you think of it? I think you use it every day in your house. You can see it every day in your house. It's one of a household item. What is it? This
Mesin
one,
basuh.
mesin basuh. Mesin basuh tu pusing 360 ke? This, for example, a blender. Okay. A good example is actually your stand fan.
Oh,
Okay.
okay.
Okay. the fan can spin 360, correct? But the movement from left to right moves from one point to another, but it is not completely 360, correct? It's stuck somewhere and then it moves back to the left and then it moves back to the right, correct? So that will be a good idea of a limited rotational motor. It might not be a motor, but it is limited, correct? So you can try and switch on your stand fan. You can see it can only move to a certain degree and then it moves back to the original position. Okay? Clear on this?
Clear, sir, clear.
Yeah. All right.
Yes,
So
sir.
simple, Okay. So single acting versus double acting cylinder. So this is when we introduce these two things. Okay. Before that, this is the graphical symbol. So this one is for single acting. This one is for double acting. What is the difference? You can see it from here. It has one port over here and it has two ports over here. So what does it mean by this is where your liquid comes in. Okay. So this is where your liquid comes in and also this is where your liquid comes out. Okay. So we have single port. Okay. Here we have double port over here. If you have liquid coming in from this side, it will go out from that side. Okay. In a case where we change the direction, if the liquid is coming from this side, it will come out through this side. Okay, that's the meaning of single port, and then we have a double port here. Okay, so for single port, this is the intake. It is also the same as the exhaust. Okay, exhaust port or the inlet or outlet. Okay, so intake or exhaust port. Okay, here double port over here, it means if this one is your intake, this one will be your exhaust, or if this is your intake, this will be your exhaust. Okay, one or the other. Okay, so the features over here, single acting cylinder, it is actually the most simplest type of hydraulic cylinder. Why? Because it only moves to one side. And then going back, we are using only single port. Single acting cylinder exert force either on extension or retraction. So extension means this is the piston. Okay. Or we call it cylinder rod. For example, let me clean this out. All right, so this is the rod. Okay, so what happened here is when you have single cylinders, it means the rod will be pushed to the right when we have an intake fluid coming in. Why? Because high pressure will push this to the right. Okay, going to the right is called extending. Okay, going back into the housing or the cylinder is called retracting. Okay, or extend or retract. Okay, so they require an outside force to complete the second motion. Okay, what does it mean by requires outside force? It means when you have, for example, the rod pushed to this side, okay, when we don't have any pressure anymore, to make this rod coming back to the position again, for example, this is what we consider as an outside force. Okay, in this part, it is a spring. So what happened when you push the rod to the right, the spring will be compressed. And then when we don't have any pressure anymore, we want to push the liquid back to the tank, we will use the spring to push it back to the left. Okay, so this is the outside force. However, for double acting cylinder, okay, it generates force during both extension and retraction. Okay. Directional control valve alternatively directs fluid to opposite sides of the piston, and force output varies between extension and retraction. It means here you have, for example, here you have liquid coming in through this part. It will push your cylinder to the right and comes out to this port. If you enter from this port, it will push the cylinder back or the rod back to the left, and it comes out from this port. So what does it mean by this is we don't have any external force, no springs. So it means if you push it to the right and you don't have any pressure coming from here to push it to the left, it will stay at the right position. This one, if you push it to the right, no more pressure from here, it will go back to the original position. Okay, clear on this?
Clear, sir.
Clear. All right. So the operation here, a piston house in a barrel with an opening in the dead end and that allow pressurized fluid to enter the space between piston and inside the barrel to push the piston outward from the inside the barrel. So rod, or we call this also as piston. Okay. All right, force can only act in one direction only, which is to push the piston out, meaning because this is where your pressure comes in, it can only push to the right. To retract or extend the piston into the barrel, gravity, outside force, or spring is used, meaning it's either outside force, spring is used to pull it back to the original position. Here on the right side, a piston house in a barrel with openings in the end allow pressurized fluid to enter the space between pistons and inside the barrel to push the piston outward. All right, the piston and rod can extend or retract depending on how the flow is moving and based on the pressurized oil. So it depends. Flow comes from here, it goes to the left. Flow comes from here, it goes to the right. So this is a simple idea of it. So let me draw like this. If you are using that kind of configuration, or it will become like this if you are using the green color combination. Okay. All right. So single acting versus double acting cylinder. For example, this is a force which is a mass and a weight. So this is external force causes retraction, meaning in order for us to have liquid coming in and out, single acting, it comes from one point only. Okay, why do we have this vent over here? Because maybe there are air pockets over here. We want to minimize the air pocket so that we can push it fully to the top. Okay, so if you have extension, it means the oil or any liquid used for the fluid power will be pushed in at a high pressure and will push the force or push the weight over here to the top. Okay, and then when we do retraction, meaning we want the liquid to come back to the tank, this weight will help push the piston back to the original position. So that's how single acting works. Okay, double acting means if you do extension, it will push the piston to the right and then the liquid will go back to the tank this way. Okay, if you do retraction, you will push the liquid from right to the left and then the liquid will come out from this way. That's how single acting and double acting cylinder is used in an application. Okay, so an example of hydraulic cylinder application, for example here, you have hydraulic cylinder. Where do you see this? Usually you will see this part. Okay, this is the cylinder. Okay, so what happened here? Here, for example, we have liquid hydraulic going to this part, for example, creating pressure and also providing fluid to push the cylinder outward or inward. Okay, the same thing also happens in this position. As long as you see a cylinder here, it shows to you that this is a part of a hydraulic system. Have you seen this before? Yes, no?
Yes, sir.
Yes, okay.
Yes,
This is a
sir.
simple
Yes,
example.
sir.
Okay. So there are formulas on how to calculate the amount of force required to push the piston outward or inward. Okay. So the calculation is based on these three different parameters. Number one is force, which is F, and it should be in Newton. Number two is velocity, which is V. Sorry. Okay, V in meter per second. And number three should be power, which is P. Okay, and this should be in watts. All right, And the analysis is separated into extraction and retraction stroke. Why is it separated between extraction and retraction? Let me ask somebody from here. Ashraf bin Muhammad, are you there? Yes, okay. Why is the analysis separated between extraction and retraction? I'm giving you a picture here. Okay, the question is, okay, for this particular analysis, it is separated into extraction and retraction stroke. Why? Based on this picture. The extension liquid comes from this side, retraction comes from this side. What's the difference between this part and this part?
One push satu cakap.
Will the force be the same to extend the piston and to retract the piston? Will it be the same force?
No.
No.
Sama.
Why?
Sebab satu tu dia tolak, satu lagi tu dia tak, lebih kurang. Betul ke?
Oh, satu lagi tolak, satu lagi tarik Sure?
Tak sure je.
Tak sure. Okay, we ask somebody else. Ungku Haziq. Are you there?
Yes, sir.
Will it be the same? Extension and retraction?
Dia punya force ke, sir?
Is it going to be the same? Yes or no? Tu je jawapan dia. And why?
No kot.
No code. Why?
Satu ke kanan, satu ke kiri.
Oh, satu ke kanan, satu ke kiri. Okay.
Lepas tu dia ke
kiri alright. So don't worry So kita nak tunjuk je whether this is normal or not Okay, so the idea here is jangan risau, apa je jawapan awak bagi, saya tak ada rasa apa-apa pun. Okay, so don't worry. Itulah sebab kita belajar. So here we have extension kan. So what happened here, when we have extension, the flow of liquid with pressure will come to this part and act toward this particular cylinder of piston. Okay, so what happened here, the area over here, alright, should be this area over here. Okay, correct? This area. Okay, the difference with retraction is if the liquid comes from the other side, for example from here, it goes to the area here, the surface area that will be heating from the liquid is only this part over here. Why? Because we have a rod over here and this space is no longer available to be pushed by this liquid. Okay, ada ni kan kat tengah, correct? So is it the same?
No.
No Okay, so the area for retraction should be smaller than the area for extension. Alright, so because of that, we might have a different force acting towards the piston. Alright, so because of that, we have two different force. Number one is called force of extension, which is equal to pressure in terms of Pascal and the area of piston. Okay, so the area of piston, like I said just now, this total area of piston can be calculated through pi r square or pi d square over 4. Alright, over here, it's the same thing, but we have a different part over here, a piston and a rod. Okay, so it means over here, we have two different area. Okay, area of piston and area of rod. So what we have to do, we have to find out piston area minus the rod area. Then you can do the calculation for force. Okay, number 2, the velocity. Okay, so number 1 is extension force. Number 2, velocity should be the same. We need to use different area also. So remember, this is coming from Q is equal to A times V. Remember this from fluid mechanics. Okay, this is area, this is velocity. So to find V, it is equal to Q divided by A. That's why the equation is this way. Right, for this one, it's the same. But remember, we have AP minus AR because the surface area is just this area over here. Right, and the last one for power, we don't have any problem for this because P times Q is equal to power. Okay, so Pascal times meter cube per second is equal to power. Or power can also be, this is P times Q, can also be F times V. Alright, so two different calculation, but it represents the same value. Okay, so it depends which parameters is available for you. So that will be the parameter that is used to find power. Okay, so let us look on one example. Okay, I'm giving you 5 minutes or 5 minutes cukup lah. Let me see. I'm giving you around 8 or 10 minutes to finish this. You can try and do this calculation right now. It's quite simple. The equation is here and the answer is here. Okay. So we don't have any answer. So I depend on you guys to do the calculation. So let's try. Okay guys, did you get the answer at least for the first one? Anyone got the answer?
Boleh sir.
Boleh Okay, so you do not know what's the answer, right? So let me show it to you. Okay, don't worry. Okay, so if it's the first time, it will take some time because you need to know this equation, right? Okay, so let me show you the answer for the first question. Right, so the first thing that you have to do is everything that you have here in meter cube per second or in Newton or in cm needs to be changed into the right unit. So 7.1 centimeter. So this is actually the diameter for piston, okay, which is equal to 0.071 meter, okay. And here is the rod diameter. So rod will be the, okay, the rod is equal to 0.0423 meter. Okay, so remember for hydraulic pressure, so remember pressure is equal to, so we want to know about the extending stroke. So first of all, you need to have the equation correctly here. So for high pressure during the extending stroke, so I have the answer here. So the area of piston, first you find out the area of piston, okay, and then the area of the rod here. So P extension is equal to force extension divided by AP. If you can see from the question, force of extension and force of retraction is the same, 700. The difference is in this part, the area of piston. So the area of piston, if I calculate it, it should be 3.959. So the answer here should be 176.81 times 10 to the power of 3 Pascal. This is the pressure for extension. Okay. So how about the velocity? Velocity is Q divided by area of piston. So Q is given here. Okay. For this particular study, hydraulic cylinder, we don't have the actual or theoretical. We just use whatever number that is given to us. Okay. So you have the answer to be 0.0053 divided by AP. So 1.339 meter per second. How about power? Okay, it's important for us to know. Power is just P times Q. If you have the pressure given in the question, or it's not in the question, it's from the calculation, use it. So 176.81 times 0.0053 for Q, you should get 937.09. However, this is power in terms of watts, okay? How do you change from watts into horsepower? Okay, you need to divide it by 745.7. Okay, so this is the number that you need to remember or note down. So to make sure each time when we ask you about horsepower, it is divided, your power is divided by this number. This is fixed. Fixed conversion from power to horsepower. Alright, so 1.257 horsepower. Okay, so this is also how, for example, your car, sometimes they provide you with the rated horsepower. So it comes from the power that is produced by the engine to your axle, okay, divided into 745.7. Then you have the idea of horsepower. Okay, any problem for extension? Yes, no, maybe?
Tak ada sir.
Tak ada. Okay, Yusri, ada problem apa Yusri?
Tak ada sir.
Tak ada. Alright. So this is for retraction. The same thing, but the difference is we have to minus the piston area to the rod area. So it will become much bigger. The number is much bigger because the area is much smaller. So this is 274 and the velocity will also increase. Okay, and also at the end, the amount of power needed is higher. Okay, and the horsepower needed is also higher. So in order for us to do retraction, it requires us to provide more power to the system. Okay, in terms of pump power, right? So because we have a smaller area, requires more power to push the area to the cylinder. Alright, quite simple kan? Ada problem? Adib ada, Adib Ramli. Adib? Ada Okay boleh
Boleh.
Boleh, alright, so good. Settle, that is for cylinder. Now we go into hydraulic motors. Okay, so hydraulic motors is different because instead of going linearly or linear movement or vertical or horizontal movement, straight line, we go into a rotary condition. So hydraulic motors are actuators with an output shaft that typically applies torque to approximately 360 degree of rotation, meaning it can spin 360 degree. Alright. The limitation might be it can only spin one direction or it can also spin two direction. It depends on whether the motor is going to be fixed or it can be changed. Alright. So system fluid enters the housing and applies pressure to the rotating internal parts. Okay, I believe you already understand how the vane works. For example, this is vane. So what happened? You have liquid coming in here and then it will spin the motor. This is different than the pump. Okay, what happened in the pump is you have the shaft driven by the pump motor and it spins this vane to increase the pressure. However, here what happened, the pressure is high from the hydraulic pressure line. It pushes the vane and it spins the vane so that at the end your pressure will be low. So this is a mechanism used to harness that power that comes from the liquid to spin it and to create work. Okay, so turbines working this way also. So hydraulic motors over here is driven by the fluid. Okay, if it's in pump, it's driven by the motor and motor is driven by the prime mover. Okay, so system fluid enters the housing and applies pressure to the rotating internal parts. This in turn moves the power output shaft and applies torque to rotate a load. Okay, once we do rotary calculation, it means that we are dealing with torque. Okay, and when you deal with torque over here, hydraulic motors are also considered as redesigned pumps, meaning pump is moving by driving the rotor here, but for our study of motor, the rotor is spun by the liquid. Okay, so you understand the idea of torque, correct? This is coming from dynamics, meaning when you learn about torque, it means that you learn about how much force is required to spin a certain application. For example, the vane. Okay, but in a rotary condition. Okay, so continuation on hydraulic motors. Okay, this is a symbol for motor. Okay, you can see from here the different symbol is given for motor compared to pump. If you remember, pump, it looks like this. Okay, so this is a pump hydraulic, motor symbol, pump symbol, sorry. This is hydraulic motor symbol, which is we have this triangular shape going inwards, okay, meaning liquid is coming inside this way. All right, and as usual, black color over here or fill inside here means that this is hydraulic. Okay, if it's this white in color, it's hydraulic, pneumatic motor. Alright, so two types of rotary actuator, limited rotation, which is oscillation motors or rotary actuators. It moves into a certain degree and then stop, it turns back to another rotation. It means we are having limitation. Number two is continuous rotating, meaning it continues like this. Okay, limited rotation hydraulic motor can rotate clockwise or counterclockwise but not in a complete circle, not in a complete circle. Okay. However, when we deal with continuous, it means rotates and RPM that is determined by the motor's input flow rate. So continuous, comparison between limited and continuous, one can spin in a complete circle, another one is limited. Alright, so we have three different rotating parts. It's either gear, vane, and piston. I believe you understand everything from this part through the video that I've sent you in terms of pumps, okay? Same mechanism. The difference is, like I said just now, pump the rotor is driven by the motor or prime mover, but for motor, the rotor is spun by the liquid. So develops torque due to a hydraulic pressure acting on the surface of gear teeth, can be reversed by reversing the direction of fluid flow, and volumetric displacement is fixed. How do we reverse it? For example, if this is the inlet port, it will spin this way and liquid goes to the other side. If this is the inlet port, it will spin this way, so it changes direction and comes out from this port. Alright, so that's the idea on how we can reverse the rotation. Alright, develop torque by the hydraulic pressure acting on the exposed surface of vane, spring pressure loaded vanes, hold the vanes, fixed displacement, balance design, and the last one is piston, develop torque by pressure acting on the end of the piston, can be fixed or can be varied, and then inline piston motor, axial piston motor can operate at high speed. These three, the same idea as pump. Okay, and as usual, gear is the simplest one, so the pressure that it can produce or the pressure that it can work with is lower than the one that we have in piston. Vane will be in between. Okay, and then operating flow will be the lowest for gear and the highest for piston, and maximum rotational speed is also the lowest for gear and the highest one is for piston. So the idea is the same as pump. Vane is in between gear and pump piston. So piston performance will be higher, gear performance will be the lowest one. Okay, so these are the three primary. For example, just now, we have the basic vane, liquid comes in, spin the vane and comes out. So this spin will create any force or torque that will move your load. Okay, axial piston motor, as usual, we have piston coming in and out based on the swash plate or the angle. Or the third one, internal gear motor, you might have gear in here and it spins the whole thing this way. Alright, so these are the formula related to hydraulic motors. Sorry, the picture over here is a bit out of focus here. Okay, this is the equation that is required for motors. Almost the same except for, okay, it is the same as pump except for, so please be reminded, there is a difference between this one and the pump, which is here. Okay, in terms of volumetric efficiency. Okay, NV over here, okay, is different. Okay, let me do it this way. NV for pump is equal to QA divided by QT. Alright. However, NV for motor is QT divided by QA. Okay, please make sure you highlight this in your notes because it is the other way around. Okay, sorry, not NVM. Sorry, let me fix that. All right, and it's also the same when we deal with mechanical efficiency. So mechanical efficiency over here, okay, for pump is equal to TA over TT. Okay, sorry, might be confusing here. Let me color code it correctly. Okay, for pump is equal to TT over TA. However, for motor, it is actually equal to TA over TT. So please make sure when you do calculation, you use the right equation. Okay, because these are two completely different idea, the other way around. So this one is for motor. Okay, any question on this?
Tak ada
Tak
sir.
ada okay. So make sure you remember this is the other way around. Why is it the other way around? Let me ask somebody. Arifin, are you there? Arifin? Are you there? Arifin? Arifin? Ada tak? Tak ada. How about Luqman Hakim? Are you there?
Sir,
Luqman
Arifin kata
Hakim.
dia tak ada mic.
Oh, dia tak ada mic. Sorry, saya tak perasan.
Ya, saya.
Luqman ada Luqman? Luqman ada mic Okay.
Ada.
Kenapa dia beza? Kenapa mechanical efficiency and also volumetric efficiency for pump and motor is different? Kita pergi ke mechanical dulu lah. Kenapa mechanical dia different? Jijing. Jijing.
Tak tahu saya.
Tak tahu Siapa tahu? Siapa boleh bagi idea? Saya petik nama lelaki satu, lepas tu saya petik perempuan satu kan. Nazira Fatin ada? Kenapa dia berbeza agaknya?
Tak tahu rasa.
Tak tahulah Okay. For mechanical seorang lagi kita try. Nurin Farisha ada?
Ya, saya sir.
Ya, saya slow je bunyi dia. Kenapa dia different Ni penting You guys learn about dynamics
Different pump dengan motor
Saya ambil satu je, mechanical efficiency. Kenapa dia berbeza? Kenapa dia terbalik?
Pump dia convert electric ke mechanical.
Okay. Is it because of that, the conversion?
Saya tak pastilah sir.
Awak pun tak pasti Okay. So alright. So idea dia macam ni. Simple For pump, the prime mover is creating the torque. Okay. So theoretically, when we create torque, usually kita calculate secara teori, torque akan jadi a certain number. For example, 100 Newton meter. This is for pump Okay. Now, when we do actual work, okay, because of friction, because of losses and everything, okay, sometimes it requires you to have higher amount of torque compared to the theoretical. So normally, in terms of pump, okay, mechanical efficiency, okay, it requires more torque, so it means that we are dealing with a higher actual torque. Okay, sebab dia nak create kan, calculate contohnya adalah, contohlah macam awak kalau dalam Waze dia kata, okay betul, if you want to drive from Pasir Gudang to Melaka, for example, to my hometown, in Waze dia kata 3 jam. Okay, however, due to traffic jam, tolls, and then you have to stop for a while, and then you are not driving at 110 all the time, so it might take you 4 hours to get into Melaka lah. Okay, so it means you predicting that 3 hours through Waze is not the same as what you are doing when you are driving in your car. Okay, bermaksud yang kita nak 3 jam, tapi yang kita dapat tu lebih. Okay, so that's the idea of it. Tu untuk dekat bahagian pump. Okay, in bahagian motor pula, alright, so what will happen is, the motor is driven by the liquid. So kita assume lah, okay, kita punya apa tu, kita punya condition, for example, kita assume to be that much. Liquid tu akan spin dia due to torque dengan torque yang lebih tinggi. Kita assume lah, kita harap macam okay, kita boleh hasilkan, for example here, kalau actual torque daripada pump is 100 Newton meter, for example, and then at the end kita nak juga 100 Newton meter. However, due to losses in between your pump through the piping, there are losses that you learn from fluid mechanics, and then it comes to your motor awak is not fully efficient, okay, so it might be some losses are there, so 100 Newton meter from here will not be 100 Newton meter on the end due to losses. So actual awak akan jadi lebih rendah daripada yang you expected. Okay, that's why your TT over TA for pump different, and then TA over TT, so mechanical efficiency will be different. Bergantung pada dua keadaan tu. The same thing for volumetric flow rate, it's the same thing also. Okay, dia the other way around. So whatever that you have, if you remember the volumetric efficiency for pump and mechanical efficiency for pump, if you want to remember for motor, you just change the nominator and denominator because it's the other way around. Any question? Yes, no? Tak ada Tak ada.
Ada sir.
Okay, how do you know whether your equation is correct or not? There's one way to know it. If the question is correctly done, okay, percentage awak melebihi 100%. Itu tak logik. Why? Because the percentage must be 100%. If the percentage is more than 100% in terms of mechanical and volumetric efficiency, it means you are doing it the other way around. Terbalik Kalau soalan tu betul, everything is done correctly, sepatutnya jawapan awak must be lower than 100%. Tak logik lah nak dapat efficiency melebihi 100% in terms of mechanical or volumetric flow rate. Okay? So that's the idea of it. So as usual, bila ada soalan macam tu, adalah soalan example question for hydraulic cylinder like this. Okay? So this is almost the same as the one we did for pump, cuma ni in terms of motor. Okay? And here we have Q1, Q2. I have the answer actually, cuma saya nak suruh awak buat sendirilah so that at least you get an idea on how to do the calculation. Alright? So what I will do is, kita tak jawab dulu. Okay? Kita akan bagi awak the next page. Okay? So let me do this first. Hydrostatic transmission. Alright? Or hydraulic transmission. I think this is hydraulic transmission. Not hydrostatic. Right? Okay, so what happened here is we have prime mover over here. Okay, so this prime mover will drive the pump. Okay, so what happened here is the input power is in terms of torque and RPM. So prime mover will drive the pump. So what happened here? It drives the pump. Okay, and then what happened? Pump output over here at the operating pressure and oil flow rate. So what happened here is the liquid here will have low pressure, low volumetric flow rate. After this, you will get high pressure, high volumetric flow rate. Here you will have the hydraulic line, or we call this as hydraulic conductors. in terms of, for example, hose or pipe, for example. Okay, and then it will come to the motor. Here, what will happen? It will create the spin, for example, just now, and create motor output in terms of torque and RPM. So what happened here is high pressure, high volume flow rate. Okay, when it comes out from the motor, it will be low pressure, low Q. Okay, and it comes back into a reservoir. Okay, so this is actually a closed system. We don't have any liquid coming in and out from the system unless at the end of the working, for example, period, every 1 month, you will check back on the reservoir. There might be some oil leakage, or this can be considered as losses. Okay, when you have these losses, you have to top up on the reservoir, and then the same liquid will be used again, and again. Okay, so this is closed loop system, meaning the loop is moving this way. On this one, move to this part, it moves to this part. So whatever liquid that you have in the reservoir will be used again, and again. That is the reason why at one point of time, we always have maintenance period. For example, after 2 years, you need to change the whole liquid, because what happened here, if we have some oxidization happening in the tube, for example, the liquid over here might be picking up some karat-karat or whatever that you have in the hose, or you might have some build up in the reservoir in terms of dust or anything if you have leakage, and that will affect our system. So that's why usually in the industry, you will do a lot of maintenance to your system, because usually for each machinery, they have their own maintenance that they need to take care of. And there's a period for that maintenance. Okay, so what we have here is, we have prime mover, reservoir, hydraulic pump, hydraulic motor, control valve, and pipe. Now, control valve is something that you will learn in the next chapter, which is how do we control the flow movement, and how do we control the direction, the pressure when it hits the motor and everything. Okay, but at this moment, between pump and motor, we do a simple explanation based on this picture. All right, any question? Yes? No?
No, sir.
Okay, so this will be the calculations that you need to try and do in terms of getting some exercise. Okay, so hopefully, please do this at home. I will not take your time through Meet because it will take your data. So what I need to do is try doing this at home. Okay, and I will ask you to send the answer in terms of Google Form. Okay, boleh
Okey, boleh.
Okay. Jawapan ni nanti lepas awak dah habis period tu, saya terus bagi jawapan untuk soalan ni, dua ni. Okay, sebab hari ni sampai esok ada satu Google Form awak kena isi kan. So ni saya minta due on Thursday lah, petang 6 PM. Okay. Okay, jangan risau as usual, kita akan ada all the jawapan in terms of A, B, C, D, multiple choice. So kena pilih je jawapan yang betul. If you calculate it correctly, sepatut jawapan yang betul tu ada. Dah habis saya minta awak buat soalan ni nanti dalam Google Form tu, saya akan terus bagi slide ni kat awak lah. Okay, slide 2 jawapan ni Alright, that's all for today.
Thank you, sir.
Okay, thank you very much.
Thank you, sir.
Hope you have
Thank
a
you, sir.
nice day. Okay.
Thank you, sir.
sir.
Okay, sure, you're
Thank you,
welcome.
sir.
Okay,
Thank you, sir.
thank you.